All right, I guess the video that I made of the two prop Z interval did not have sound, so this is me re-recording it with sound. It'll actually go a lot faster because you don't have to wait for me to write. So this first one is just the template, and I'm just gonna, I would say, pause it and write all this down. You're gonna scroll down to the bottom part, and again, I would pause it and copy that down. And then I'll talk through the example that I did in class. So the example that we did in class, we said we had 30 out of 80 males in a sample that we have made up voted Democrat, and 40 out of 100 females voted Democrat. So the problem gave you this information, and then asked you to make a 95% confidence interval. So talking through what I'm doing here, so P1 is the true population proportion of male Dems, P2 is the true population proportion of female Dems, and we're trying to find out the difference between them. I don't even really care what either of them are. I just want to know how far apart they are. So we're going to try to estimate P1 minus P2, and it doesn't matter if you do P2 minus P1, or females here and males here. As long as you're keeping what you're doing consistent through the problem, you are okay. And 95% confidence level. So the conditions, we got to do the same 3 conditions we did before, but now we're doing them for 2 samples. So randomness stated. I did when I wrote this problem, I put randomness on. But you're just saying for both. Both samples are independent, and then I'm just kind of verifying over here. 80 is less than 10% of all males. 100 is less than 10% of all females. And I do have at least 10 successes and at least 10 failures. So 30 successes for males, 40 successes for females. And then like the other people, so these other 50 and these other 60 would be considered quote unquote failures. You can name success and failure whatever you want. Don't try to take any political commentary from the math and work. So we got our formula here. My point estimate is the difference between them. So before, when I had like one sample, it was just p hat, and now I want to know the difference. Critical values, Z star, and then the standard deviation formula. You will not have to memorize this. 0.375, which I got from doing 30 out of 80. 0.4, which I got from doing 40 out of 100. 1.96 is inverse norm of 1.95 divided by 2. And then you're just plugging the numbers into the formula. Let me run through how to do it in the calculator. I think that was on the video without sound. So you would go stat, tests, stat, then scroll over to tests, scroll down to number, it's letter B, 2 prop interval, 2 prop Z interval, and put in our info. So we had 30 out of 80 in the first sample and 40 out of 100 in the second sample. We wanted a 0.95, and there's our answer. So we're pretty sure that the 2 things are this far apart, somewhere in there. So here's our interval. I do need to be able to convert that into like writing it in this form. So this number you could get 2 ways. One is it's like literally just doing that subtraction. 2 is that's the average of these 2. So you add these 2 up and divide by 2, you get this number. And then this number is this distance. Yeah, okay. It's the distance from one of these to the other divided by 2. So you can do 0.118 minus negative 0.1681 divided by 2. Or it's the distance from one of the endpoints to the middle. So you can do like 0.118 minus negative 0.25. That's how I got that. And then our conclusion, we are 95% confident that the difference P1 minus P2 is between these things. So hopefully that covers everything. I apologize for not putting sound on the first one. We got template, we got example, we got how to do it in the calculator. All in under 5 minutes. Go us.